part, which was our calculation. So calculation's always our favorite, I know. So this is Q equals MCAT, and you heard me say cat, right? So that's because everyone I know, we always learn it where the C is right here. We say M and then C delta T, all right? But it's not really an A, but it looks like that. So Q equals MCAT, that is your calorimetry equation. It's what we use to quantify this heat idea, how much stuff got transferred. And so basically what we're seeing is Q is your change in thermal energy or your heat, and it's measured in joules. So if we have kilojoules, what number is related to kilo? 1,000. 1,000, right? So it's 1,000 joules in 1 kilojoule. Mass we're going to measure in grams. That's going to be our M. All right, so if I have kilograms, again, 1,000 grams makes a kilogram. Delta T is temperature change. We have final minus initial. Those of you going on to our advanced physical sciences, you will definitely be using final minus initial for a while, all right? And even AP Bio, you will when you start seeing the graphs that you see kind of on the other side of this page. And then C, specific heat of a substance, is what we were just talking about. And everybody has their own value. So we will be hopefully looking to figure out what substance we have by figuring out its specific heat value. So the calculation example that you have, it's also number 1 on the right-hand side of this page. Okay, so if you want to copy down the work over there, you can. So just walking you through it, says how many joules of heat energy are required to raise the temperature of 550 grams of water from 12 degrees Celsius to 18 degrees Celsius. Okay, so matching this up, Q equals MCAT, right? We're solving for Q, right? So joules of heat energy was Q, so I left Q alone. And I set that equal to M was the mass. So 550 grams, we don't have to convert it. Just leave it 550. I multiplied that by C, my specific heat, 4.18. That value can also be found on the back of your periodic table. It's labeled as 1 calorie. Okay? And actually, what I'm going to do here. Might help to just follow along with it. All right, so we have Q is who we're looking for. Okay, and we're setting that equal to our mass, which was 550. C was 4.18. Okay, you can ignore the little 4. We don't ever use it. But just to be clear, that calorie that I just told you was on the back of your periodic table right here. Okay, the 4.1 joules. 1.8 joules. 1 calorie, that is not the same thing as the calorie that you eat. When the ones that you're counting when you eat is actually a kilocal. All right? So it's 1,000 calories. Just so you know. Cool? All right. Usually I get that question. All right. So back to this. So then we had the 4.18. I'm going to multiply that then by my change in temperature. So my change in temperature, we're going to always do final minus initial, right? So final minus initial. So looking at those values, I have 12 to 18. So which one goes first? 18. So we're going to say 18 minus 12. So ultimately we have 550 times 4.18 times 6. When you plug that into your calculator, you would end up with the number, I believe, 13,000. What is it? Like that? Yeah, okay, cool, perfect. All right, so we have 13,794. That is in joules, okay? It's in joules. All right, so that's going to be kind of what we're doing, all right? So the only other thing that I would like you to copy down in terms of this page is me giving you a couple helpful hints for number 2, because number 2 and number 3 are actually extremely ugly because they both have the conversions in it. So you might add to the top of your page that 1 kilojoule is equal to 1,000 joules. 1 kilogram is equal to 1,000 grams. And then if you are ever going from kilo to joules, all right, or kilo to normal, you need to multiply it by 1,000. If you are going from normal to kilo, you need to divide it by 1,000. Okay? Hopefully that makes sense how I kind of have those arrows. It might help you with those things. What that also means, though, is 3 to the right when you're multiplying, 3 to the left when you're dividing. The other thing that might help you on your assignment today, 1 milliliter of water, for sure, we can assume is equal to 1 gram. And so for the most part, even if we give you like acid and base that you're mixing, if we give you the milliliters, because that's what we measure, the volume, we can go ahead and say that's equal to their grams. Okay? Okay, so for number 2, just because number 2 and 3, those are probably the ugliest ones, just because they have that extra conversion in there. That's all I'm going to do, and then I will leave you alone for that, okay? And we'll flip it over, look at the graphs, and we'll do the Schoology assignment. All right, so this says for number 2, how many kilojoules of heat energy are necessary to raise the temperature of 350 milliliters of water from 1 degree Celsius to 5 degrees Celsius? So the first thing to notice is it says how many kilojoules of heat. So I know that I am solving for Q, kilojoules of heat, because I'm solving for heat, Q. The fact that it wants my answer in kilojoules, and on the last question, that gave me joules, that means that whatever answer I end up getting, the very last step has to be divided by the number 1,000. And I would say that's the part that just makes this a little difficult. All right? So hopefully looking at that, you're like, that's not difficult. That's good if you feel that way. All right, so Q is who we're solving for. All right, then when looking through, we see 350 milliliters. So that goes with what we were just saying. 1 milliliter of water is 1 gram. So therefore, my mass, we're able to use that little assumption, our mass then is 350 grams. Easy. Okay, that would be the next challenging thing. All right. Then the rest of it, we have C is going to be 4.18, okay, specific heat. And finally, delta T, I'll just put it down here. Delta T, we're going to take final minus initial, so it's going from 1 to 5. So what does that mean? It's 5 minus 1, which is 4, okay? Just to give you the heads up, look at number 3. That one's going from 880 to 13. Is that one going to be a positive delta T or a negative? That one's going to be a negative delta T, okay? So negatives exist. All right, so knowing those different things, we have Q is equal to 350. We're going to go ahead and multiply that by C, delta T. So when we multiply those 3 together, we get the answer 5,852. But that's in joules. So in order to get it into kilojoules, what are we going to do? Exactly. We're going to divide by that 1,000. So you'll end up with 5.85. Since that says 3 digits, 3 sig figs, we'll say that kilojoules. That's your final answer. Okay, so it's not bad. It's just conversions, I know, aren't always our favorite thing. Okay, for the most part, this whole page is the same thing. Number 4 and 5, we change it up and we say, hey, get your specific heat, get your mass. All right. So feel free to write those 2 down if you want them or come see them later. That's fine. But let's go ahead and flip the page and talk about the graph on the other side real quick because you need that one for the assignment today. Okay, so you will have a one of these calculations, but you will also have stuff about the graph. So I'm going to